I was talking about pressure in liquids. Pressure in liquids. And if you remember, the topic that we discussed here was pressure increases with depth. What all did we study here? Pressure increases with depth. And some of the application oriented questions were, why is the walls of dam made thicker at the bottom? Why can't you reach to the bottom of the sea or to the bottom of a swimming pool, which is very, very deep? Because the pressure is very high and you won't be able to sustain that pressure. इसमें एक और चीज देखते हैं. So let's say I have a tumbler and I have filled this with liquid, okay, and that liquid can be water. That liquid is water. One of the things you should know, all these you learn in higher classes much more better. Here they have not introduced the concepts with formulas, so it is all like gulping. Suppose you take any level. Have you understood? It is filled up. It is filled up with water. Let's say it is filled up. We fill this up somewhat till say till here. I have filled it up, okay, and I have taken any level, and this level from the bottom is suppose at some height. Let's say it's some height and is filled up till here. Is this understood? So in 3D, you should imagine that in 3D we can imagine that there is a surface at this level also. Don't you understand? We are able to understand? Like say a liquid in a tumbler, the liquid has a level, right? This is the surface of the, say, the liquid is filled till what position? The liquid is filled till this position. So this is the surface of the liquid. Have you understood? But I am trying to go little bit below and I am at this surface. Have you understood? This surface is like a circle floating on that tumbler. Every point on this circle is at the same height. Are you able to visualize or not? Right? So how do I tell you? Let's say I have got a water bottle. This is empty. Suppose this is filled till here. I want to see it at this height. At this height, every point on this circle, there's a circle out here, right, is at the same level. Here what we say, the pressure will be same at all points. The pressure, see, if you want to find out, sir, what is the pressure here? What is the pressure here? What is the pressure here? What is there? All these will be at the same pressure. Remember that. Pressure at all points at the same height is always equal. Have you understood? समझ में आया कि नहीं? What I've tried to say, the pressure will be equal. One of the way that is actually proved by experiment is, if you make a hole here, say suppose I create a hole here and I create a hole here, both the holes are at the same level, pressure is exerted equally. Now another thing is, how does water exert pressure? It will be exerting pressure equally in all directions. How do you prove it? Suppose sometimes when you go in a road or you are traveling through a train, you will see one pipeline which is leaked, water pipeline. You will not see water only going up, water is going down also. Pressure is exerted equally in all directions by a liquid. So the liquid is exerting pressure on all sides of the wall. If you make two holes out here, you will find water gushing out and they will actually fall at the same distance. Now why they are falling at the same distance? Because their pressure is same. Have you understood? Pressure is same. Let's make this topic a little bit more interesting now. Now, the more interesting what I do is that I create one hole only out here, right? And I create another hole here, I create another hole here, I create another hole here. And all of them I have plugged with my finger, filled it up, and I just remove my finger, right? First tell me, which point has the highest pressure? The lowest point has the highest pressure. मतलब वहां सबसे जोर से किक गिर रहा है, तो यहाँ से जो पानी निकलेगा ना, ये सबसे दूर गिरेगा. Here it will go like this. Here it will go like this. This you can actually do at home also. We used to do it, taking some tankal powder or take any old water bottle. You know how to do it, but you should be very safe. Take an old water bottle and do it in supervision. Gas on करो, एक screwdriver लो, so gas में गरम कर लो, and make some punctures. First mark the water bottle and then mark some punctures on that. समझ में आया? 3 punctures, not more than that, else you will not be able to manage. Now fill the water bottle and put your fingers like a flute player, and then suddenly move your fingers away. and then you will see the water is gushing out from the bottom one at the highest speed. Have you understood? That means pressure at the bottom. So we are staying on high-rise apartments. We are staying on high-rise apartments. Now you should ask application. Somebody is staying at ground floor also, like say Uzair. Uzair stays at second floor. His building is 19 floors. 19 floors. Where is the water tank? Right at the top. So from 19th floor to this floor, who feels the maximum pressure? The ground floor. He also is feeling very high pressure. That means, but if you look at 19th floor person, they have less pressure. So ideally, if the tank is connected to everyone's house, by the moment he switches on the tap, he should be flushed away. So much should be the pressure. And the 19th floor guy should not be able to take any bath itself, because once he opens, his pressure is very less. तो उसके shower से तो पानी निकलेगा ही नहीं. Are you understanding the concept? But if you go and visit his house or the 19th floor, you'll see same amount of water is coming out. So how we control it? We have got booster pumps in the whole society. The pumps will maintain an equal pressure in all floor. Otherwise, the 19th floor guy will never get water supply. His water, if you only, how is the water coming from the tank? By gravity. He would have got the least amount of water pressure. So we have got pumps. These pumps regulate the pressure. And this guy should have been washed away. है ना? टैप खोलते ही एकदम आलू प्याज टर्न करके उड़ जाएगा सब. ऐसा तो नहीं होता है. So we regulate. Or even you will see, whenever your AquaGuard person comes, he will always bring a pressure gauge. He will check the pressure, because the pressure is very high at lower floors. Upper floors, the pressure is not high. So they will not allow so much of water pressure to get inside the AquaGuard. It will destroy its membrane. Is this concept understood? So, wow. So what did we understand here? Pressure increases with depth. If such sort of a question is given and they say, where do you expect the water to flow out with the maximum range? The bottommost. Why? Because the depth of this point is the most, and pressure increases with depth. The previous example, what we say, pressure, a liquid exerts pressure in all directions. How to prove a liquid exerts pressure in all directions? Take a gubbara, balloon, fill it with water, tie it, and now take small, what do you call, syringe, and make holes in that. You will see equal, just like corona, water is coming out equally in all directions. So pressure is exerted, liquid exerts, keep it written, liquid exerts equal pressure in all directions, and pressure at all points at the same height of a liquid is equal. Pressure at all points at the same height is equal. Remember that. Pressure at all points. So in liquids, we learned three things. Pressure at all points at the same height is equal. Number one. Liquid exerts pressure in all directions. Number two. And the pressure at the bottommost point is the highest. Three things. What are the three things we studied? Pressure is equal at all points on the same height. अगर आप एक ही height पे किसी भी point पे compare करो, you take a bucket and you fill up the bucket, say till half. Every point on that half has the same pressure. How to prove it? Make two holes on either side of the bucket. You will see water gushing out to the same range. Number one. Is this number one thing clear? Rest you can break down it into your English sentences. What did we learn? Water, liquids exert same pressure at a same height. At the same height, the pressure exerted by liquid at all points is same. I see my words can change, but you should understand what I'm trying to say. At the same height, all points feel the same pressure. Number two, what did we say? Number two, we said that liquid exerts pressure in all directions. Liquid exerts pressure in all directions. What is the example for that? Balloon filled with water and multiple punctures made. You will see water coming out in all directions. Or a pipeline which has punctured at 2-3 points, big water pipeline, you will see water coming out like a fountain on all sides. Yeah.
If you take like a sharp puncture the balloon with water, so
actually needle na, minute injection needles, tick 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 tick. Got it? उसके लिए थोड़ा भारी. Nowadays you all don't play with it. When we were kids, we used to get two type of balloons. One is to be called a water balloon, which is what like you play with yo-yo. we used to have this during our Durga Puja and Dashera times, a balloon which is filled with water. That is to be a heavier balloon. You can't inflate it. You will have pain in your cheeks. So that balloon used to be filled up with water. No, very small balloons. But the skin is very hard and thick. So there you can puncture with injection needles. It will not burst out. And the third one we said, pressure at the lowest point is the highest. What is the proof of it? If you make a container like this, then the water gushes out from the bottom point at the highest one. All 3 points clear? Okay. And another thing I missed out, the instrument used to measure atmospheric pressure is called a barometer. Instrument used to measure atmospheric pressure is called a barometer. And the atmospheric pressure, the atmospheric pressure is measured by an instrument called barometer. And the atmospheric pressure is measured in millimeters of mercury. Mercury is Hg. Millimeters of mercury means how many millimeters will a mercury column rise? The actual definition is like this. See children, we take a porcelain tray and this tray is filled with mercury. On this tray, we will fill this tray with mercury. We'll fill this tray with mercury. This is filled with mercury. Okay, liquid mercury. Understood? And we will take another tube. We will take another tube like this. And this tube will be graduated in centimeters. Let's say this is 1 till say 100 centimeter means no, it's not test tube, it's called a graduated tube. Test tube does not have marking. This will have marking. 1 to 100 centimeters means it's a 1 meter tube. Have you understood? This 1 meter tube, what we will do, we will fill it up till it's brim with mercury. इसको भी mercury से भर देंगे. So this is known as Hg. Right? This is filled with mercury and say यहाँ पे थोड़ा सा बड़ा करके रख लो, यहाँ पे भी थोड़ा सा mercury है. And then we will put our thumb on it. Thumb means totally seal it. And then invert and put it inside this trough. This is known as a trough. Trough. This is called a trough. On this trough, we will fill it up with mercury and then invert it, put it inside, and then release my thumb. So if I release my thumb, what will happen? Some mercury from this tube will come out. Do you agree? Due to gravity, it will come out. So, aisa rahega. The tube is now inserted. So here we have got the 100 mark. I say tick, 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 tick. Some mercury will be falling on this trough. Agreed? But you should also appreciate that this trough is experiencing atmospheric pressure. There is atmospheric pressure. So why not? It is open to atmosphere. Everyone experiences atmospheric pressure. So the atmospheric pressure will be now pressing the mercury. So mercury will try to again rise up in this column. This rise of mercury will happen only up to 76 mm. This is say 1 to 100, say millimeters. Sorry, not centimeters. So, it's correct, centimeters. So you will see that it is rising only up to 76 centimeters. Means beyond this, there won't be any mercury rise. Did you understand, children, what we are trying to say here? You filled it up completely with mercury and you inverted it here. Removed your thumb, some mercury will come out of here, right? Due to gravity. But gravity will be opposed by atmospheric pressure also. कुछ निकलना चाहता है, कोई नीचे से दबा भी रहा है. So एक balance create होगा. And with that balance, mercury will rise up to how much? 76. That's where we say that the atmospheric pressure is said to be 760 mm of mercury or 76 cm of mercury. हमेशा अर्थ में वो इतना में थोड़ा आगे पीछे हो सकता है, but it will be around this only. One atmosphere is 760 mm, or we say 760 mm or 76 cm. The same, right? 1 centimeter is equal to 10 millimeters. So this much of mercury will be there. In fact, when you go to a doctor and you measure your blood pressure, Arnav, you kindly mute your line, beta. You measure your blood pressure. Your blood pressure is measured in two counts. One is called systolic divided by diastolic. This you'll learn in bio later. A normal person should have 120 by 80, 120 mm of Ag and 80 mm of Ag. This is normal blood pressure. Systolic. No, this is DBP. SBP is systolic blood pressure, diastolic. The heart pumps out again, it will cycle. Systolic by diastolic. Any person who reports more than 120 has high blood pressure. Like you will have people aged who are having 140, 160. This crossing over 200 is a serious attention. Immediate, you should be rushed to hospital. And anybody who is below 80 is known as a person who has low BP. Low BP treatment is very difficult. High BP with drugs we can make it down. Low BP happens when people have a lot of anxiety, unwanted worry. Unwanted worry will shoot this also. Low BP is a by birth problem. Low BP person should not be too much in depression mode, should watch more of humorous things. आपकी BP अगर बढ़ी है तो हम उसे घटा सकते हैं. But we don't have drugs in which we increase BP. So if you are a low BP patient, there are many low BP patients. Low BP patients will be usually thin, anorexic. You know anorexic, थोड़ा सा पतला पतला खाना नहीं खाता है, तो automatically आपको देखने से पता चलेगा his BP is low. So if the BP is low, there are potential chances you will lose consciousness. इसका medication नहीं होता है. Very, very difficult. This is called hypertension. This is called hypotension. Have you understood? This is hyper. But this brings a very interesting thing in discussion. That if this is your artery, right? Or your artery, which is this artery, the brachial artery that we have, right? And you puncture this with a needle. Now, what is this? What is this 120? This 120 is nothing but the blood that is flowing inside is actually creating a pressure on the walls of the artery. That is the pressure that you have measured. How much is the maximum pressure? The 120 is the maximum pressure that the blood is putting on what? The arterial walls. Now let us have a nice discussion on this, okay? Ab interesting discussion karte hain. And the discussion is, you ask many people, they will not be able to answer this. This is your artery. ये आपका artery है. यहाँ से क्या जा रहा है बेटा? Blood is flowing through this, okay? No confusion, blood is flowing through it. You are a normal human being. So what is your blood pressure? Your blood pressure is, the maximum is 120 mm of mercury. है ना? And this is inside your body. Inside your body. So this is you. And we have magnified a portion from your body and we are trying to see that, okay? This is the magnified portion. Now we do a puncture out here. यहाँ पे हमने एक puncture कर दिया needle से. What will happen? Blood will flow out. Okay, very good. Blood starts to flow out. एकदम चाप करके blood निकलना शुरू हो जाता है. But you see the mathematics. See the mathematics. Right now, don't you think atmospheric pressure is acting on you, on all portion? So atmospheric pressure is also acting on this hole. Yes or no? ऊपर से pressure आ रहा है 760 mm of Hg. This is atmospheric pressure. Blood pressure मार रहा है 120 mm of Hg. फिर खून क्यों निकलता है? Did you get the mathematics? The atmospheric pressure is 760 mm. The blood pressure is 120. चलो इसको थोड़ा blood pressure दे दो इसको. Make it 140 की जगह इसको 160. He's a hypertension. His blood pressure is more. More blood pressure means more quickly the blood will ooze out. But कैसे ooze out होता है? You see the economics is not working. Not economics, the mathematics is not working. आप समझ रहे हो? There is a pressure of 760 on the hole. Inside pressure is how much? 120. Pressure तो same है ना. Area छोड़ो, वो सब हो गया. Now we are talking typically in terms of pressure. You don't say I have got more jewelry, we are talking money to money. Yes. Are you able to appreciate the problem or not? First of all, what I'm asking, have you understood what I'm asking? All of you. I'm saying there is a atmospheric pressure of 760 on that hole. Yes or no? And the pressure of the blood is 120. Then why is blood oozing out? Blood should not ooze out. कुछ तो गड़बड़ है. Are you able to trace that गड़बड़? यही तो साइंस है. आप एक चीज नहीं ध्यान दे रहे हैं. हाँ, तो मूव करने दो. मूव करो. तुम मूव कितने प्रेशर में मूव कर रहे हो? 120 पे. 120 पे है ना. ब्लड बाहर कैसे आ रहा है? फिर आना नहीं चाहिए. लेकिन यहीं पे एक और एग्जांपल देता हूं. अगर एक आदमी को मरे हुए 7-8 घंटा हो गया है, देयर इज नो एक्टिविटी इन द बॉडी, नो एक्टिविटी एट ऑल, अगर आप तब जाके उसके हाथ में पंक्चर करोगे ना, ब्लड नहीं निकलेगा. हाँ बोल. What if there is some pressure? What did you say? Tell me, बच्चा.
Because there is some pressure still coming up.
You are again saying two things. I am saying this fellow has got 760 rupees. This fellow has got 120 rupees. Whose buying power is more?
120.
इसके पास 760 rupees है, इसके पास 120 rupees है. Whose buying power is more? 760. But here we are finding buying power is more of 120. मुझे वो आंसर चाहिए. मुझे वो आंसर चाहिए. एक पाइप ले लेते हैं, उसके उस साइड से आप 40 mm ऑफ Hg प्रेशर से ब्लो कीजिए और मैं इस साइड से 80 mm में ब्लो करूंगा, तो क्या होगा? मेरा हवा आपके मुंह में घुस जाएगा ना. आई डोंट एक्सपेक्ट योर ब्रेथ टू कम इनसाइड मी. यस और नो? बट देयर हियर ऑपोजिट इज हैपनिंग. व्हाई? This thing many people at job level also in interview don't answer. Simple. The blood is also under the impact of atmospheric pressure. Blood also, every object senses atmospheric pressure. So the blood also senses atmospheric pressure, and add 760 mm to this also. Now how much is the blood pressure? 820 mm of mercury. 880 or whatever. This is called absolute pressure. This is what the doctor measures. So this is called gauge pressure. So when you go to a fuel pump, you will always see PSIG written. PSIG means pound per square inch gauge, what the machine is measuring. Here atmospheric pressure has not been taken into account. This blood is also, mathematics तो tally करना पड़ेगा खून निकलने के लिए. अब खून निकलेगा? अब निकलेगा. But when you are dead, is your heart beating? No. So this 120 is gone. अब मर गए हो ना, ये 120 चला गया आपका. अब अंदर प्रेशर कितना है ब्लड के लिए? 760. बाहर प्रेशर कितना है? 760. फिर भी अगर आप एक मरे हुए आदमी को 5-6 घंटा बाद भी पंक्चर करोगे ना, थोड़ा सा ब्लड निकलेगा, मे बी, बिकॉज स्लाइट रेमिनेंट प्रेशर इज स्टिल देयर. हैव यू सीन समटाइम्स the washroom, you have that faucet pipe. If you disconnect the bulb also and you press it, some water will come out because there is a trapped pressure already. But once the trapped pressure is released, no more water will come out. मरे हुए आदमी के बॉडी में भी हार्ट बीट बंद हो चुका है, लेकिन थोड़ा तो प्रेशर है. प्रेशर कुकर को गैस बंद कर दिया, फिर भी खोलने से ट्रैप प्रेशर तो है, थोड़ा सा ब्लड निकलेगा, उसके बाद और नहीं निकलेगा, बिकॉज होल इज नाउ ओपन. What is the pressure outside? Atmospheric pressure. What is the pressure inside? Atmospheric pressure. No blood comes out. Let me give you one more example. How many of you have experienced watching movie late night in any mall? Means आप theater से निकल रहे हो something around at 2 AM or 1 AM. जब मॉल बंद हो चुका है, but only the theater is open, and say something like In Orbit Mall. Okay. Now imagine you have entered the mall not from basement, but you are entering the mall from the main entry, right? At the main entry, there will always be something called a collapsible windows doors type thing. It opens automatic. As soon as it opens, right above there will be a blower unit which is blowing air. Feel हुआ है कि नहीं कभी? The mall is a charged unit. Mall जैसे सुबह शुरू होता है, the person will actually switch on the AHU, which is called the air handling unit, and the mall is pressurized. The entire mall is pressurized. Usme, it's just like aircraft, we have pressurized it. Why do we pressurize it? If you don't pressurize the mall, every time you open the door, outside air will get in. It will take more time to cool the mall. And in mall, the same air circulates right from the washroom to the KFC where you are. तो आप ये मत समझो कि KFC में बड़ा प्यारा सा एयर है, इसीलिए तो कहते थे in during COVID that you have more chances of getting COVID if you go to places which are air conditioned. Air condition में एक ही गैस, एक ही एयर सर्कुलेट करते रहता है. So in shopping malls, whether it is the air of the urinal, the same air is coming inside the movie theater. We don't allow you. That's why when you open this door, there is a big jet which you keep on feeling. That big jet is pressurized, right? अभी सुनिए, मान लो आप मूवी देख के रात को निकल रहे हो 1-2 बजे मॉल से. At that time the mall is closed. You will see that by the time you come out of the movie theater and you will be made to walk through the same mall area, all the escalators are closed, only one may be running. Typical scenario at night. ये एयर हैंडलिंग यूनिट स्विच ऑफ हो जाता है क्योंकि एसी तो नहीं चल रहा है. आप देखोगे मॉल में एक अजीब सा सन्नाटा हो गया है, राइट? एट दैट टाइम when you are exiting by the main door also, nothing is on top of you. In cars, have you seen one switch below the AC? In cars there is one switch below the AC which shows like this, and another switch which shows like this. Means this is this button on. When you are running air condition, this should be on. This on means the air of the car is circulating, which is cooled, and this means you are allowing fresh air to come from outside. So suppose you are crossing a road and a buffalo is dead for 8 days. So it will give you or not buffalo, some pile of cow dung is lying, my favorite example, and it is smelling horrible. At that time, if you switch on this button, that air will be coming inside in your car. So in air conditioners like this, or you have eaten too much that you are exploding air in the car, then also you will open this. Otherwise, this will
That is basically the window.
not windows. It is just below the AC. The AC controls. गाड़ी में जब बैठते हो ना, don't sit like idiots. You all are science student. See everything around the instrument panel. You will see these two buttons. One is showing you circulate the same air. In air condition, we keep this on. It will be foolish to run this. Every time new air is coming and we are spending more and more fuel to cool the air. Have you understood? So in a mall, we maintain positive pressure. The mall is pressurized chamber. You should also ask a question. When we actually switch on the gas, why does air not go and enter inside the what do you call cylinder? Suppose we have not ignited my gas stove. I have just turned on the gas. हाँ, गैस लीक होने दो ना, होने दो थोड़ी देर गैस लीक. एयर क्यों सिलेंडर के अंदर नहीं घुस जाता है? बाहर तो एयर है ना. सेम, द सिलेंडर इज प्रेशराइज्ड. Cylinder pressure plus atmospheric pressure. Air को क्या है? Only atmospheric pressure. So who wins the battle? LPG wins the battle. That's why LPG comes out. Have you understood? Correct. Sometimes when there is water supply is turned off in your apartment, there will be some tank cleaning. You must have left some tap open. So what is happening? Air is getting inside the tap. And after 4 hours, when the water supply will be restored, you will first listen whistling sounds from the tap. Have you experienced? And water will come out in intermittent. ऐसे निकलेगा जैसे फट फट के निकल रहा है पानी. That's all because नहीं काला नहीं. The water will not come out continuously because there is water locks in between. The same thing happens in your blood. Have you seen before giving an injection, the nurse or somebody will take up the medicine right to the brim of the needle and leak out little bit of the medicine. Why? तेरे बॉडी में अगर एक बूंद एयर घुस गया ना, वहीं के वहीं मरोगे. And they will click it so that there cannot be a one drop of air, bubble of air cannot be inside the needle. If it is inside the needle, you're gone. Huh? But blood cannot take air pockets in it. You are like that water tap. ऐसे करके पानी जाता है ना, देखे हो कभी? पानी का सप्लाई जब बंद हो जाता है, उसके 7-8 घंटे बाद जब आप टैप ऑन करते हो, You will say, sir, our taps were closed. तो क्या हुआ? तुम्हारे बाजू वाले घर ने बंद करना भूल गया होगा, एयर तो घुस गया है. And it will sometimes create airlock also. The plumbers will be running. Water won't come out. Air will create a lock in between. At that time, what we have to do? We have to seal this side and open this side so that the entire air comes out. Only then water flow will start. How many of you have got coolers at home? Cooler जिसमें हम पानी भरते हैं. Okay, cooler में we use, I fill water in my cooler using pipe. Pipe is lamba. So suppose today my water cooler water filling is over. Then what will I do? I'll take out the pipe, coil it back, and I keep it in a bucket so that water does not leak. Do you mean to say that all the water in the pipe was used up? No. So tomorrow when I go and again put that pipe, there is some residual water and some residual air. When I first switch on the tap, it will make sounds like this. ऐसे कुछ sound करे. सब air. Once all the air has been flushed out, you will hear no noise. Then it is melody. ठीक है? आपने एक और चीज देखा होगा, अगर किसी को सलाइन दे रहा है ना, suppose a saline bottle or a packet has been changed. Nurse has changed this packet. When nurse will actually put the cannula in your body and turn it on, then automatically this has got three things. It has got atmospheric pressure, and pressure in higher classes you will study varies as density into acceleration due to gravity into height. Density of the liquid is not in your control, whatever it is, medicine you have to take. Acceleration due to gravity is 9.8. Height. जितना ऊपर ये nurse इसलिए stand में रखते हैं. Salines have stand, and those stands heights can be adjusted based on the person's body pressure, because the person's blood will also give a pressure. Now are you understanding? The fight is between the blood and the medicine. Somebody who has got high blood pressure, uske liye you will see the nurse has actually increased the height because she has to increase the pressure. Then only the medicine will go down. But you will see, after she has injected, she will take 2 needles and she will prick those 2 needles out here. Observe these things. That is mandatory. If you don't put needle out here, it will straight away compact. ऐसे crush हो जाएगा ये. You are sucking in and atmospheric pressure will suck it out. So once you put the needle, air goes inside. Air will do 2 jobs. Help you to pump the liquid back into your body as well as keep the bottle inflated. Otherwise bottle ऐसा हो जाएगा. Water bottle को अंदर से, और ये सस्ता वाला जो बिस्लरी का bottle, not बिस्लरी, some सस्ता water bottle, if you take and you suck inside, then what happens? The bottle will crush, implode. The same thing will happen here. Next time when you go to a hospital, you're attending some patient or something, a lot of interesting things happen. And those have nothing to do with medical. Those are all engineering things. How does blood get into your, how does the medicine go into? You should ask, sir, ऐसे होल कर देने से तो blood आ जाता है. How are you able to put that medicine inside? Syringe we can understand, somebody pushes it inside. इसमें कैसे जा रहा है? ना कोई मोटर, ना कोई पंप, फिर भी जा रहा है. सर इसको नीचे कर देने से जाएगा क्या? अच्छा, when we donate blood, what do we want blood to come out? तब हम इसको ऊपर नहीं रखते. You will be idiot. Blood cannot reach here. Atmospheric pressure blood को दबा देगा. Then we will put it below the bed, and they will give you something to squeeze in your hand to increase your blood pressure, ताकि खून और easily निकले आपके बॉडी से. क्लियर है ये सब? छोटी छोटी चीजें हैं. चलिए आगे बढ़े. मजा आया? समझ में आया? तो you can go and ask that if our body pressure is, blood pressure is 120 and atmospheric pressure is 760, why does blood come out? But blood नहीं आना चाहिए बाहर. What people don't add is the atmospheric pressure is also acting on the blood. अब कभी कभी डॉक्टर को भी पूछ सकते हैं, वो भी 1 मिनट के लिए सोच लेगा, फिर आपको लगा नो यू टेक केयर ऑफ दिस. इतना सवाल क्यों पूछता है ये लड़का? ठीक है, चले, लेट्स गो फॉर डेसिमल वाला स्क्वायर रूट अभी.